Hello everyone, I am Prachi and in this video we will start with a new unit that is benzene and its derivatives. So benzene is the simplest aromatic compound and you may know that the structure is something like this. And the derivatives will have the same ring but it will be attached to some other groups that are known as the substituents. So it may be OH, NH2, SO3, COOH, CHO. So there can be various groups that will be attached to this benzene ring and those compounds will be known as the derivatives of benzene. So in this chapter we will start with learning about the structure of benzene. In this unit I will be explaining you about the structure of benzene, stability of benzene, aromaticity, reactivity, that is the reaction that benzene undergoes, and finally we will discuss about the preparation of benzene. So let's start with the structure of benzene. But before we start with the structure of the benzene, let's see some few things about benzene. So this we know that benzene is an aromatic compound and this compound exists as liquid and it has a smell similar to that of the petrol. And whereas if we look at the melting and the boiling point of benzene, then the boiling point of benzene is 80 degrees Celsius and the melting point is 5.5 degrees Celsius. Benzene is flammable and it is the most simple aromatic hydrocarbon. And if we look at the solubility of benzene, then it is a non-polar compound. So it will be insoluble in water, whereas it will be soluble in other organic solvents. Also, benzene is carcinogenic, that is, it may cause cancer if we are exposed to benzene for a longer period of time. So these were just the few things about benzene. Now let's come back to the structure of benzene. So the elemental analysis and the molecular weight determination showed that the molecular formula of benzene is C6H6. Now if we take a look at the alkane with 6 carbon, then the formula will be, so the general formula for alkane is CnH2n plus 2. So if I put the value of N, that is 6, because here benzene is having how many carbons? 6 carbons. So if I put the value 6, then what is the molecular formula we will get? We will get C6H2 into 6 plus 2, that is C6H14. But the molecular formula of benzene was determined to be C6H6. So it has 8 hydrogens less than that of the alkanes. So this shows that benzene is an highly unsaturated compound. It was German chemist August Kekulé who came up with the structure of benzene in 1865. Kekulé did the structured elucidation of benzene and described it as a snake biting its own tail. And this structure, that is snake biting its own tail, that came to him in his dream. So by this he gave the ring structure of benzene, in which the 6 carbon will be present in a ring and there will be alternate single and double bonds. Now let's see what are the evidences that supports the Kekulé structure. So by now it is known that the molecular formula for the benzene is C6H6. Now with that formula, first thing that we can do is just see the open chain structures that are possible with the molecular formula C6H6. So let's take a look at the open chain structure that are possible with C6H6. So by that time it was known that the molecular formula, so the scientists knew that the molecular formula was C6H6. Now the thing was to come up with the structure. So the first thing is to look for the open chain structure. So there was absence of open chain structure. So the first thing is that was observed is that the benzene, it does not undergo reaction with bromine. It does not react with bromine in presence of CCl4. So the structure, whatever structure they came up with, will depend on the observations, right? The kind of reactions that benzene is showing. So it was observed that benzene, it does not react with bromine in presence of CCl4. Also, it does not react with dilute KMNO4 or it does not react with water in presence of acid. So benzene was not undergoing any of these reactions. So now the structures that can be possible, open chain structures we have to see. So it is C6H6. So we have to take 6 carbons. 1, 2, 3, 4, 5 and 6. This is the 6th carbon, right? So now we have to fit in how many hydrogens? We have to fit in 6 hydrogens. So 2 hydrogens I can put here. So if I put 1 hydrogen here and the other hydrogen I'll put at this position and rest 2 here. How many hydrogen? 4, 5 and 6. Now let's put the bonds. So here double bond with these 2 carbons will be attached with triple bond, and again here there will be double bond. So one of the open chain structure that is possible, that can be possible for benzene is this one. Similarly, the other structures can be CH triple bond. Now triple bond can be at the terminal position, CH2, CH2, C triple bond, CH. So you have to take care that the number of carbons is 6 and number of hydrogens is also 6. So possible open chain structure are these. Other structure can be CH3, C triple bond C, C triple bond C and CH3, right? So other possible structures are these, and we know the valency of carbon is 4, so it will be forming 4 bonds only. So fit in the hydrogens, put the bonds. If it was possible that it had the open chain structure, then benzene should have undergone these reactions and along with the reactions that are shown by alkenes and alkynes. So with this molecular formula, that is C6H6, the open chain structures are these. So as you can see, it has double bond and the triple bond. Here are the triple bond, here are the triple bond. So all these structures are having double and triple bond. It means that the compound with this molecular formula should undergo the reactions that are shown by alkenes and alkynes. But this was not happening for this compound with the molecular formula C6H6. So the open chain structures were rejected. So it was concluded that benzene cannot be open chain compound. It cannot be a open chain compound. So the first thing was rejecting the open chain structure depending upon the reactions that are shown by the compound with the molecular formula C6H6. Now the other thing that Kekule proposed was that it has the double bonds. Now let's see what are the things or the reactions that proves that the benzene has double bonds. Now we have to look at the presence of double bond. So what Kekule proposed was that there is alternate double bond. So if there are 6 carbons, then there will be alternate double bond. So if we are adding anything, then how many things will add to it? 6, right? To make a saturated compound, right? So whatever will add at these position, already here we are having hydrogen. So the reactions that shows that it has double bond is, first is the halogenation. So when benzene undergo halogenation, there is a addition of, or we say chlorination, if we are doing chlorination or bromination, anything, then there is a addition of 6 halogen atoms. Now the other reaction that shows the presence of the double bond is, so the reduction reaction of benzene. So it undergoes reduction. So the molecular formula is C6H6. So it will undergo reduction. Reduction is the addition of hydrogen. And reduction is always done in presence of platinum and nickel. That is the catalyst. Here also, how many hydrogens will add? Just now we saw 6, right? How 6 halogens are adding. In the similar way, 6 hydrogens will add to benzene, giving cyclohexane. And the other reaction that shows the unsaturation is the reaction of benzene with ozone. So this halogenation is the first thing that shows the presence of the double bond, then the reduction of benzene, and third is the reaction with ozone. So with ozone, benzene forms triozonide. Now what is that molecule? So let's take a look at the reaction. So simply we know, by that time it was not known that the structure is this, but we know that the structure is this. So we want to look at the reaction. So it will react with 3 molecules of oxygen and we have carbons here, right? There are 6 carbons. Now ozone is O3. So how many atoms of oxygen will add like this? 3 atoms. In the similar way, because the unsaturation is at these carbons, or it will be at the other 3 carbons. So that we don't get confused, we can put the double bond like this, right? So ozone is adding up here and it is adding here. And similarly, the double bond is present here, it is adding here. But it can be at the other places also, because it has 2 resonating structures that we will see later. So it forms triozonide. So all these reactions shows that the benzene contains 3 double bond. Benzene contains 3 double bond. How? Because number of hydrogen or chlorine or ozone that is adding is 3, correct? The ozone are adding is 3, its molecules are 3, so the atoms will be 6. So 6 hydrogens are adding, correct? 6 halogens are adding and 3 ozone molecules will add. So this shows that it has 3 double bonds. Now let's take a look at the reaction that gives us the idea of the ring structure of benzene. Benzene, if it is heated to its boiling point and in the presence of ferric bromide, yields monosubstituted compound. That means if we are taking benzene, so this was the structure proposed by Kekulé. It will react with bromine in presence of FeBr3 and will give mono-substituted benzene. And this can only happen if benzene exists in ring structure. So this is mono-bromo-benzene.